Let's think about the or sentential connective and then the so-called disjunctive syllogism. The term or really has two different possible interpretations. There's the exclusive or, and then there's the inclusive or. Now, in mathematical logic, the or is an inclusive or. Always, always, always. In other words, if you have the molecular sentence P or Q, the disjunction, there are really three possibilities. Namely, that P is the case, that Q is the case, or both P and Q are the case. So 1, 2, 3. Three possibilities. So when we're interpreting this sentence, P or Q, always keep in mind there are three possibilities. Conversely, the exclusive or only has two possibilities. Namely P or Q, but not both. Obviously, in ordinary conversation, in ordinary English, we often use the or in an exclusive sense. So this just raises the question, how would we translate an or exclusive into mathematical logic? It's not difficult. You just have to have a little patience. Just think about what this sentence is saying, P or Q. There are three possibilities. So how would we translate X or Y where the or is exclusive? So we can first say X or Y in parentheses. Presently, that's saying X is the case, Y is the case, or both X and Y are the case. But we want to deny that third possibility. So let's do that. We'll just say and it is not the case that, parentheses, X and Y are the case. So this attachment, so to speak, essentially denied that third possibility, and so we have translated correctly. So now we can get into the so-called disjunctive syllogism. Or DS for short. Let's say we have the first premise, P or Q. Second premise, not P. So what can we conclude given those two premises? The first premise, P or Q, so P is the case, or Q is the case, or both P and Q are the case. But we're told that P is not the case. So therefore Q must be the case. So therefore Q. For example, either it's moving or it's stationary. It's not moving, thus it's stationary. By the way, if you prefer Latin, the disjunctive syllogism we can also call modus, tollendo, ponens. But what if someone made the following argument? With the first premise, P or Q, the second premise, P, and then they say, well, since we have P or Q and P is the case, it must mean that Q is not the case. Well, clearly this is invalid. And it's invalid precisely because it's not understanding that the or sentential connective is an inclusive or. So just because P is the case, it doesn't prevent Q from being the case. After all, there are three possibilities, P, Q, or both P and Q. So this is clearly a very bad argument. Yet, it does have a name. It's called modus ponendo tollens. Now, in Aristotelian scholastic logic, oftentimes the or is an exclusive or. So, insofar as we have an exclusive or, this argument would work, but never in mathematical logic. And so, while the modus tollendo ponens is a very good argument in mathematical logic, modus ponendo tollens is never a good argument in mathematical logic.